Working Party 7B on space radio communication applications. Now, what's very important to realize, and I would like to stress that once more, it was already pointed out by Mr. Yvon Henry, is that ITU is you. ITU comprises of the delegates from administrations, academia, as well as sector members. So essentially, anyone that is involved in these entities can participate in the work in 7B. So also, if there's any small satellite developers out in the room, I would really invite you to get in touch either with your administration and to get involved in the national preparatory process, or if you're academia, to consider becoming an academia member of ITU. The group meets twice a year for a meeting of approximately 5 days. The last couple of meetings have been in Geneva. And these meetings are input-driven, so they're contribution-driven, which means that any administration can, and any member can contribute documents, and those will be taken into account in the meeting. And if appropriate, they will be taken into account in the output, which again are documents. And in the case of Study Group 7, and in the case of the work that we're doing here, what we're producing is reports as well as recommendations and so on and so on. Now, the work that Working Party 7B does in relation to this agenda item is twofold. So you remember the study question that I highlighted before, and the task of the group is to answer the study question. Now that has happened, and we have generated a report which contains the characteristics, definitions, as well as spectrum requirements of these nanosatellites and picosatellites. So you can directly see the question reflected in the title of the report. So that's a report which was finished in October. I invite everyone to look it up on the ITU website. You can download it free of charge. And secondly, the work which is ongoing right now is the response to the invitation, as was set out in the resolution, to examine the procedures for notifying space networks. So examining Article 9, 11, Appendix 4, and see whether they are suitable for small satellites and whether they need modification to enable the deployment of these nano and picosatellites. So this report is under development at the moment, and it's expected that this report will be finished at the next meeting in May 2015. Now, I hope I've been able to give you a little bit of a background of the work that we've been doing so far. I would now like to give the floor to Mr. Martin Buscher from TU Berlin, who will present you his work in relation to the work in 7B. So if you give us a couple of seconds to switch the microphone.
Okay, good evening, everybody. Hope everybody can hear me, but I think it's okay. Okay, like Wouter already said, I'm working at the Technical University of Berlin. You may ask why I'm here, why I'm standing here and presenting the work of an ITU study group. So back in 2012, when the different administrations were assigned to answer these questions, what are characteristics of the pico and nanosatellites, what are their spectrum requirements and everything, the German administration realized they don't have any knowledge about, or not too much knowledge about small satellites because they never built any. So that's why they asked the Technical University of Berlin if we can consult them in committee work towards the World Radio Conference 2015. And that's why I'm standing here. I'm right now consulting the German administration and the German Space Agency in these questions. So as you know, I am a small satellite developer myself, which is good because I know the problems that small satellite developers have, because my university has the same problems as many of you maybe. And yes, so that's why we tried to answer these questions. And so how did we do that? In the beginning, we were some people just thinking, okay, what might be the characteristics of pico and nanosatellites? And it has been mentioned earlier, everybody says a typical mission might be something like a satellite smaller than 10 kilograms, maybe having edge length of smaller than 30 centimeters. Short development time of maybe 3 years or less, and mission lifetime of 2 years. That's just some ideas that people had. So after we were discussing these, we finally realized, okay, we only had 3 or 4 opinions of people who said that. We need some database. We need some data from which we actually can derive the characteristics of nano and pico satellites. And especially what is more important, what are the characteristics which are relevant from a frequency management perspective? We also had this question earlier today. How can the mass of a satellite be relevant from a frequency management perspective? It's not relevant at all, and also nobody can prove if a satellite which is in space already is now 10 kilograms or 15 kilograms or 20 kilograms. And also, what about microsatellites, for example, which are 50 kilograms? What about these? Should they be excluded from a definition of small satellites which might have other regulatory environment than classical satellites? So for that reason, we set up a database, and now the good news for you is that all the upcoming slides are on a poster outside, so I can skip most of the content. But I want to just let you know that what is in this database that we created just to answer these questions. So we have various parameters per system. It's the name and the operator, contractors of the system. We have mass and dimensions, of course, just to be included in these characteristics. We have the purpose, like if it's just technology demonstration or if it's some Earth observation satellite or educational mission. We have a lot of data about the communication system, about which bands they use, about the RF output power, about bandwidth and everything. We have a lot of information about the orbital parameters, how high do they fly and when do they know about their orbital parameters and all these things. Like I said, the data is outside on a poster and it's also available online. You can check the poster, there's a link on that data. That's why I'm skipping most of it. Also, we have some things about timelines. First, development timeline, also regulatory timelines that apply to pico and nano satellites or to basically to any satellites. But what is important here is the problems that small satellite developers have with those regulatory timelines. Mission success, what can we see here? Mission lifetime. And it's about, I think, 100 parameters per system. We right now have 450 small satellites in this database. And so we thought, okay, that's a good database. That's a good basis for actually defining small pico and nano satellites like we were asked in WRC 12. So in the end, we came up with some definition. First thing with these definitions, we can only define a small satellite right now with the mass and the size. And the first thing that we realize is, okay, the size is not it's not a strict value, it's not a clear boundary. For example, a nano satellite might be 10 kilograms or might be still 15 kilograms. So that's the first result that we have in the reports, that we don't have a clear definition, a distinct definition of small satellites. But that is something that is very typical for nano and pico satellites. It's the mass and the size, and also maybe the orbital parameters, or at least the late knowledge of the orbital parameters, and the launch arrangement, that it's always a piggyback launch and that there are many of these small satellites launched together. But however, like I said, the characteristics which are relevant from a frequency management perspective are not so distinctive. So it's not possible at this moment to realize or to define a regulatory definition of small satellites or of pico and nano satellites. That's the first result which we had from these discussions in the group, in the working party 7B. So the second question that was asked was, what are the spectrum requirements for nano and pico satellite systems? And that has mentioned earlier today too in other presentations. Nanosatellites and picosatellites as a distinct class cannot be defined from a spectrum requirements and frequency coordination perspective. So there's so many different, there's no real standard for small satellite communication right now. So for that reason, we can't really define the spectrum requirements. It could be, and we don't know about the future of upcoming systems. There might be different spectrum requirements which we cannot derive right now. And so it is at the moment not possible to answer this question both for current and upcoming missions. I think I remember we once tried, or the ITU in the beginning tried to define some spectrum requirements for small satellites and came up with some data about maximum RF output power. And at this point, suddenly the ISS was a small satellite as well, just if you're looking, or at least one transceiver from the ISS, an amateur transceiver, was a small satellite as well. And so, as you can see, it's very hard to define this at this time. So the second question that we were asked in these reports are, what are the spectrum requirements for nano and pico satellites? And we answered this question by saying we can't answer the question. That was the second result. So in the third result, the third question was, under which radio communication services can systems using nano and picosatellites operate? And we heard that by Ola earlier, the first BeepSats, or satellites which only could send a little beacon, used the amateur satellite service. We still have a lot of satellites who are using amateur satellite services. For TT&C, for example, or if they are an educational mission or an amateur mission, they also use the amateur satellite service, and they should use it, and the amateur guys are supporting the use of it. But more and more services, or more and more small satellites, are some sort of commercial maybe, or at least industrial, and have some more use, or some more functionality than they should do in the amateur satellite service. And for that reason, they're getting out of the bands into space research service, space operations service, which we can also see in the database that we created. So in the end, what we can say is nano-satellites and picosatellites are not bound to any kind of radio communication service. They are right now already operating different kind of services, so we can't really say that there's one single service or two or three which they use. So actually, by that, I won't repeat that, but the three questions that we were given that we should answer in the study group are answered. First one, that we can't, that the distinctive characteristics are hard to tell, at least from a frequency perspective, a frequency coordination perspective. That we can't answer the spectrum requirements right now without having a standard for small satellite systems, and radio communication services, in fact, they could use any kind of radio communication service. So the second one that thing that we should do is we should examine the procedures for notifying space networks and consider possible modifications. So what we did, we looked at the ITU radio regulations, especially Article 5, this is the table of frequency allocations. Article 9 and 11, you already heard that, they are about the API and the notification of satellite systems. And Appendix 4, that is the part of the radio regulations where they say which kind of data is mandatory for an API and for a notification. So we looked at this regulatory environment first. Then we also looked at the development time, the short development time of small satellites. We looked at the mission lifetime of satellites, maybe is that something special about small satellite systems. And also we looked at the problems and needs of small satellite developers. So what we did is when we created this database, we took it from online resources or online sources, but also we tried to contact every satellite operator and ask them, hey, where are your problems? Do you have problems with the ITU? Do you have problems with the national administration? And or with some other regulatory environment, to find out what is the problem, how can we help them? And so the first results that we had were we looked at the Articles 9 and 11 and decided that these articles should not be modified at this point, or do not have to be modified at this point. The radio regulations are there for a reason, they make sense, and we should not try to change them right now. Somebody said earlier that we might, I think it was Mario Neri who earlier said, first we should try to get all the satellites into the working environment and then decide whether it's possible or whether we must change something. So that's something similar that what were our results as well. So second was, if we're talking of frequency allocations, when I talk to somebody who doesn't know anything about the regulatory environment, they always say, hey, don't we have some special frequency allocation for small satellites, or can't we create something like that? And the result that we had very early in the process was you cannot arrange a frequency allocation for a satellite class. Frequency allocations can only be arranged for satellite services. And the third and very important thing is small satellite developers need training and assistance in the application of regulatory procedures. So small satellite developers have to learn for themselves that it's important, that these procedures are important. They have to be aware of the regulatory timeframes, especially, like how long does it take to file a satellite. And so that's very important that they themselves, or we ourselves, like I said, I'm a developer myself as well, we have to be aware of these things, and we have to train ourselves, but also the ITU and the national administrations have to help them and have to support and assist them in learning these procedures. I think the ITU is doing that right now with this workshop here. They have another workshop they try to give people more tutorials and hands-on material online, like they